Alright, hello everyone. I hope you guys are doing good. So today I will be attempting this Leetcode Bi-weekly Contest 72. It's about to start in a few seconds. Well, I'm not really regular in doing Leetcode contests, but I was like really free today. So I thought, why not just attempt this and record myself? So I'll be doing that. And let's hope it goes well. Okay, let's start. Where are the problems? Okay. Given a zero indexed array of length n and an integer k, return the number of pairs I less than j such that both the numbers are equal and I into j is divisible by k. What are the constraints? Okay, constraints are small. Okay. So n is nums dot size. For I is equals to 0, I is less than n, I plus plus. For j equals to I plus 1, j is less than n, j plus plus. If nums of I equal to nums of j and I into j mod k equal to 0, that's the condition, right? Yeah. I will increment my answer and I'll just return it. What's this? 4, right? I'll just submit this. I think it's accepted. Yeah. Let's move on to the second problem. So given an integer, return 3 consecutive integers that sum to n. Okay. So what I want is x. So 3x plus 3 should be equal to num, right? This should be long x plus 1 and x plus 2. So long. So if num mod 3 is not equals to 0, I'll simply return the empty vector. Otherwise, x is num by 3. Ans dot push back x, ans dot push back x plus 1, and ans dot push back x plus 2. Return ans. Let's see. $33 is 10, 11. Wait a minute. 33 is 11, 12, 13. Why is that happening? Oops, I have to do x minus minus. Yeah, this is good. Move on to the next problem. This is accepted. Okay, so we are given an integer final sum, split it into a sum of maximum number of unique positive even integers. Okay, the following splits are valid. 2 plus n, among them 2 plus 4 plus 6 contains the maximum number of integers. Note that final sum cannot be split into. Okay, so this is, first of all, the final sum has to be even, definitely. Otherwise the output will just be empty. Other than that, what can we do? Number of integers. So if I start with, what are the constraints? Okay, constraints are large. I have have to represent this number as a sum of even number, and the number of such numbers should be maximum possible, right? Okay, no one has actually solved it till now. Let's see. So 12 is 4 times 3. Similarly, 28 is 4 times 7. I don't think that's related. So what do we do here? So if we take consecutive small numbers like 2, then 4, then 6, then 8, what will we end up with? Finally, we will end up with an even number which we will have to take. But I think this is it. Let's say, for example, we are dealing with 28. So we take 2 plus 4 plus 6 plus 8. So we already have 20. Now we will need 8. So instead of 8, we can just replace it by 16. And the final result will still be 4. I think that should work. Yeah, it should. Okay, so we have our answer vector. Okay, but the thing here is the constraints are large. I didn't take that into account. We have to apply some math to figure it out. I don't think that's very difficult. So what we need to do is, we need to find the first term in this arithmetic progression such that the sum up to that term is greater than this final sum. So 2 plus 4 plus 6. I think we can simply apply brute force here because that would be O of square root of n. Yeah. So long cur equal to 0. Also, so what do we want to do here? So we also want to maintain the sum. Cur should be 2. What are the constraints again? Okay. So yeah, if final sum is odd, then I can simply return my answer vector. Otherwise, let's start. So we'll just have an infinite loop. So if sum plus, let's just say cur, yeah, sum plus cur is greater than final sum. If sum plus cur equal to final sum, then I will just say that you push back cur and you break out. Otherwise, what you do is, so if sum plus cur is less than final sum, what you do is you just push cur into your answer. And increment cur by 2. Otherwise, long back is answer dot back, and then you pop it, and then you increment back by cur. Sorry, not cur. What you do is, okay, first of all you also have to increment sum. So sum plus equals cur here, and here what you do is you will simply increment final sum minus sum. Yeah, I think this should do. Breakout. Let's see. So for 12 I'm getting 2, 4 and 6, and for 28 I'm getting 2, 4, 6, 16. I think this should do. Let's just check again. Sum is 0. Sum plus cur is less than final sum. Then you will just do it. Otherwise, yeah, looks good. Let's submit. Yeah, it's done. Great. How many people have actually? A lot of people have done it. Okay, so off to the last problem. Just one person has solved it. So let's try it out. So we are given two arrays of length n, both of which are permutations of 0 to n minus 1. A good triplet is a set of 3 distinct values which present in increasing order by position, both in nums1 and nums2. In other words, we consider the index of the value v in nums1. Okay, then a good triplet will be x, y, z such that, okay, so in both of these permutations they should appear in this order. I have to count the total number of good triplets. That makes sense. That makes sense. Okay. Let's see how we can do it. Of course, the constraints are large. So one thing which I am thinking here is that we should iterate for y, definitely, and we should kind of fix y. So if we iterate for y from 0 to n minus 1, we have the position of y in the first array and in the second array. And I want to find a number of pairs x, z such that x appears to the left of y in both the arrays and z appears to the right of y in both the arrays. How do I do that? So basically, I have to take all the numbers whose position is greater than the position of y in the first array, similarly in the second array, and somehow get their union, and that too quickly. I'm sorry, not union but intersection. Yeah, that's what I'm supposed to do. Like I need to find those numbers which are let's see. So if we fix y, find the number of numbers whose position is to the right of p1 of y in nums1 and p2 of y in nums2. So both these conditions have to be satisfied. Let's see. have this prefix and I have this prefix. I have to somehow take the intersection of a prefix or count the number of numbers which are same in a prefix. How do I do that? I think I can just keep prefix sums. Like one idea that I'm having is to keep something like a segment tree for 1 to n and only add elements into the segment tree when I'm going from left to right. And then what we can do is we can represent the numbers which have been taken by 1 and which haven't been taken by 0. Maybe that won't work. Okay, yeah, that won't work. Not a lot of people have done it till now, so it's definitely a hard one. Prefix here and prefix here. I need to find the number of numbers which appear in both these prefixes. How do I do that? Okay, one thing that I can do is to take the contribution of every number. Like every number will contribute after a particular prefix in the second array. Yeah, I think I can do it using an ordered set, because in every prefix I just need to find the count of elements. Yeah. Okay, so that's okay. Let's just copy paste this order statistics stuff. I hope it's possible to use an ordered set in Leetcode, because otherwise we are going to have some serious issues. I don't even know where we have to paste this thing. Let's try to see if it compiles. Okay, maybe it should be outside. Again, compiler. Damn it, we can't use an ordered set here. Okay, maybe this is the problem. Yeah, this is okay. Let's see. Ordered set of pairs, or maybe only integers. Okay, so the plan is I will insert the position of all the numbers in P2 in the ordered set. So I have to make this vector pos 2. So pos 2 of nums2 of I is equal to I. Okay, and now let's go. Also I have to do this for the prefix as well as suffix. So let's create two arrays, prefix and suffix. Now I need to find the number of values. So int current position is pos 2 of nums1 of I. Now I need to find the number of elements which are strictly smaller than this. So that would be given by what's the thing, order of key. Okay, so prefix of I is nothing but st dot order of key of curpos, and then I will insert this position into my set. Now I will clear the set out and iterate in reverse order. This should be n. This time what I want is something similar. So I want the number of elements in my set whose value is strictly greater than this. So that would be the size of my set minus the number of elements which are strictly smaller. Yeah, and this would be suffix of I. And now I just need to add them. Answer plus equals to prefix of I into suffix of I. Okay, let's see. Compile error. What's the problem? Okay. Let's see. Again, compile error. This should be nums. Okay. One and 4. Let's submit it. Runtime error. Damn it. Signed integer overflow. Yeah, this should be long. Now it should be good. Okay, so this sums it up.